In this video, we are going to talk about why we were allowed to solve one-step inequalities involving addition or subtraction by simply treating them as if there are one-step equations using addition or subtraction. So let's check it out. We're going to head back to these problems here in a second. I'm going to just talk about how the inequality sign does not change when we add or subtract the same number to both sides. So let's start out first by adding the same number to both sides of an inequality and seeing that the inequality stays the same. So if I add, let's say, 4 to both sides of an equation. Sorry, I said equation, inequality. If I add 4 to both sides of an inequality, I will not change the inequality itself. And we'll see that in a second here. If I add 4 to -3, I will get +1. But that is still going to be less than 1 plus 4, which is 5. Our original inequality stated that -3 was less than 1, and adding the same number to both sides of the inequality did not change the distance that these two numbers are apart, nor did it change the fact that the number on the left was less than the number on the right. Let's see further why that is on a number line. Well, we started out at -3 and at +1. +1 was 1 to the right of 0. -3 was 3 to the left of 0. So we know -3 was less than 1. By adding 4, the -3 would go up to 1. So that's where -3 basically jumped to. But 1 would go up to 5. So the two values are still 4 apart, just as they were 4 apart to start. And so the value on the right is still more than the value on the left, or the left is less than the right. So we can add the same number to both sides of an inequality and nothing changes. The same thing happens with subtraction. I could subtract, let's just subtract 2 from both sides of this inequality. That is true. 5 is greater than 4. We know that because 5 here is further to the right of 0 than 4 is. If I subtract 2 from both sides, I will get that 3 is still greater than 2. And that's because by subtracting 2, 4 gets shifted to the left 2, and 5 gets shifted to the left 2. And so we notice that this value is still 1 more than that value, or 3 is still greater than 2, because 5 is still greater than 4. So the main idea here is if I add or subtract the same number to both sides of an inequality, the inequality sign stays the same for these reasons. Now, that means that when we're solving inequalities, we can treat them as if they are simple one-step equations using addition or subtraction. Multiplication or division we'll get to in a later video. That's cool stuff. So we're going to undo -3 by adding 3 to both sides, just like you would to any old one-step equation. We've undone -3. That zeroes out, and so we're left with x, same inequality sign, is greater than or equal to -4. Not bad. In this one, we're going to undo +30 by subtracting 30 from both sides of the inequality. The -30 cancels out here, isolating x. The inequality does not change directions. X is still less than or equal to 10 minus 30, which is -20. And in later videos, I'll go over how to graph out the solutions, much like, well, we did in a previous lesson. That's it, folks. The goal here to show you that if I add or subtract an integer, or really any number, to both sides of an inequality, the inequality signs remain the same.